Hi everyone, David Mala here. Today I'm going to show you some really cool stuff. Outside we got what's left of hurricane flow, tropical storm flow blowing, but inside we're going to be working on some cool stuff with some data. So let me show you what we got right here on the right is some correlations, and I'm going to show you how to pull that up. We're going to do random forests today. So what I've got right here, you can see if you haven't installed any of these packages that we're going to be talking about, this is all in R by the way. But if you don't have these packages installed, all you do is use this right here, install packages, pick the one you don't have, put it in there, and then down below right here you'll see the two packages I'm bringing in, caret and performance analytics. Now down below this is where we're pulling in the iris data set. So you can just hit, this is our studio, very simple to work with, just control and enter, and you've pulled in your data set. Now, what we're going to do is down here, let me show you this. Let's open this up a little bit. And about there. And so what we're going to do, I'm going to explain this and walk you through how we're going to do the random forest on this. So first what we're going to do is we're going to take our data set, the iris data set, we're going to put this into a data frame, okay? Because without putting in a data frame, we can't access like we're going to do down below. So we do this. It's in the data frame now. And now that it's in this data frame, there's a table set up that makes it so it's much easier for us to access the different fields, columns, change data types, things like that. So next, what we're going to do is we want to create a condition. So in this case, we already have a data set. So if we look at this, and I were to just take the data set one here, right, just like that, hit Control Enter. This is some of our data right here. And it shows you we have 5 columns, right, sepal length, sepal width, petal width, right, that's 4, plus species. Species has 3 different types, setosa, versicolor, and virginica, right? So there's 3 different ones. So what we're going to do is we're going to create a new column right here called Dataset1 class, $class. And we're going to base that on if this dataset on species, this column, is versicolor. If it's not, it gets a no. If it is, it gets a yes. So let's do that right here. Control and enter, and we've done that. So now, if you look at data set 1? Now we've got 1, 2, 3, 4, 5, 6 columns, and the 6th one tells us yes or no if it is set to that. If it is versicolor. Next, what we're going to do is we're going to change it from text because that is now text, and we want that class section to be a factor. So the difference is this is text right here. We want this to become a factor. So let's hit this because without that it won't work correctly for what we're doing down below. Now it looks the same if we were to go look at it. If we hit Dataset 1, or we could hit Dataset 1 class, and you hit enter. Now the difference is if I did this before I did that, let's go back and if I redid this, let's redo this and show you the difference. See how that's yes and no? If I did it before it, it would have yes and no but inside of double quotes, and that won't work for us. So watch, if I hit this again, we bring in the data set iris, we bring in this, right? It's in the data set, and we do this, we've got yes and no, right? So we have class, but now if I do this without changing it to a factor is down below. Remember what we're showing right here? Down here where it's yes and no. Well, now watch what happens. See the difference? So if they're in double quotes, that's text. We don't want that. So that's why we're running this line right here to get rid of that. And once we've run that line, we do it again. And see watch how the double quotes are gone. It's factor versus text. Okay, now what we want to do is we have a species column, right? And we also have the class column. We don't need to have both, but we want to make it so we're running a test on this too. So what we're going to do is we're going to take the dataset 1 column species. Now remember, we're not doing it in the actual iris dataset, but in this data frame that we've created, we're going to set it to null. That way, if we were to look at species, instead of seeing it before where it had those 3 different types in there, with versicolor and virginica and the other one, instead, now it's just going to say null. So that has no bearing on our random forest. So now, what we're going to do is we're going to go and graph the correlations of this. We want to see it is going to make sense. Can we go and figure out, based on our data here, these these columns that we have here. So if we go back here, there's our columns. See how now we no longer have species in there? We have these 4 we had, and then we have class. We do not have species. But what we want to do is see from this, what are our correlations? That's what this is right here. So if I run this code right here, chart, correlation, data set, -5 is because we have 5 columns, okay? And column that we're interested in is class. So what we got to do is take this, enter that, and this is our numbers that we get here. We can bring this up and make this bigger if we want. And from this, you can see we have some very high correlations. As things approach 1, that's very good positive correlations. As they approach -1, that's very good negative correlations. So as something goes up, it directly goes the opposite, would be if it was negative. So what we're looking at is this guy right here, these guys right here. We've got a lot of good correlations in there. So now, and that's with sepal length, width, petal length, and petal width. See all that? So that's how that works out. Now let's go and minimize that again so we can see our screen here. Now what I want to do is I want to create a model based on what I have right now. I want to create a model and I'm going to train it based on the factors we have in there right now. So what you see right here is I'm building the model and I'm training it based on class, see that, of data set 1, method equals random forest, it's RF, the tune length, the method, cross variable and cross variance, and the number is 15. So how many trees down do I want it to go? How accurate do I want it? Obviously, the more the trees you have, the more accurate it'll be, but at the same time, the longer it'll take to run. This is a small data set, so it's not that bad. But if you had a great big data set, this could make a huge difference in how deep your trees run. So I found with this data set, 15 and 3 are the optimal numbers. So if I hit Control and Enter here, it's running it, see down below, and then when it's done, it brings the arrow back, which means it's done. Next, we can go and either get our results from just hitting the model right here, running that, and that gives us our accuracy, which is very high. We have 95% basically, 95.1, 95.95, 95.2%, 95.9% for these two. We can also run it by using the results on it for the results column, and that does the same thing. It returns our accuracy, kappa values, and then our standard deviation of the accuracy and kappa values. Then what we can do is we can create a prediction based on that. And what this will do, let me show you right here. If I hit so this is predict of the model, which is we built that right up here, on the original iris data set for probability. So if we look at that, let's just click on this and see what we've got here. We've got is all these values of a yes and no column. So right there, you've got, by running that, we have the no column and the yes column. Okay. We could also go, instead of looking at the whole thing, and just get the head of it, which is the top 6 rows here. We could look at tail and look at the bottom 6 rows easily. And you can see here clearly these are no's and these are the yeses, and obviously that, 0.998, that means that's going to be a no versus a yes of 0.002. Now what we can also do to test this, to further test this, is we can go and take this data of the yes and no columns and put it into one column. That's generally what you're going to want to do for graphing purposes. And what you're going to do is you would create a if-else statement like this, where in this case, remember, we've just created the prediction into a data frame called pred. And so I could say, because it's got a no column and a yes column, we can say if pred no is greater than pred yes, see that right here, pred yes, then 0, because the no gets a 0 value. And then we could say, in the other case, if it's the opposite, then it gets a 1. So that's how this formula works right here. And that puts that in a new field or column called iris class, because we did not have that in our original iris. So without running this, let's take a look at the iris data set right as is. And if we look at that, we have to the right, remember, we did not get rid of the species column in the original iris data set. We did that when we took that and put it into a new data frame called Dataset 1. But in this case, we have the species still there. And what we want to do is we want to compare what we have from our prediction value based on the random forest model that we created up above, and put that at 95, 96%, and put that right up next to our species column here and see how accurate we are. Right? It's going to be pretty accurate. Obviously, we can see it's 95%, 96%. Didn't we see that earlier? If we run that again here, there's our accuracies, 96% basically for the last two of the models. So let's just run this. What that's going to do is, I told you, it's going to put it in that class column. And once we've run that, now let's go back to our original iris data set. So we can do that here by this. We can do it up here by this. Oh, there we go. Let's get that. There we go. And when we run that, look at now, we have, see that one extra row at the end? So remember what we were doing originally was to see if they were versicolor, right? Virginica is not, so look, they're all zeros, right? Oh, there we go. There's some ones. What does that mean? We got versicolor, and we're right on par. Look at that. All the versicolors are ones. Look at that. All of them. And then it goes to Setosa, which is the other one I didn't remember earlier. But that's not versicolor. So see how those are all zeros? Look at that. So if you go through that, we are 100% accurate in this case. Now it's saying from our random forest modeling and that stuff that we're going to be about 96%. In this case, we have a low number. What do we have? 150 rows here of data. So we are 100% accurate at 150 rows. That's pretty good. So that's how you build a random forest on a data set, and we created our own test set by removing the entire column for species, setting it to null inside of Dataset 1. Now you can also do sampling, and we're going to do that in our next video and show you how instead of removing the entire set, first what we did here was we built a training set based off that. We used that to create our model, and then we went back and took our values that we got from our predictions with the random forest model, and we put that back into the original data, iris, and then we compared it. And you can see right there we were very accurate. Now you can also do this with sampling, so instead of taking the full thing, I could have taken, you know, and this is what you would want to do in a larger data set probably, is take maybe 20% as a test out and use the other 80%, and I will show you how to do that in our next video. But this is basically how you do random forest. This is on the iris data set. It's out there. It's publicly available. You can just go on Google, type in iris data set, free iris data set, something like that. Data science data set iris, flowers, whatever, something like that, to pull that up and utilize that, do what we just did here. Again, we use the caret and performance analytics packages in RStudio, and we came out with some very high accuracy results, and I showed you how to get the correlations off that, how to fit your model. So we could have changed these numbers, by the way. I could have changed this 3 to a 2. I could have changed it, left it at a 3. I could change this 15 to a 10 and have fewer trees and see what that would do with the numbers. I wonder what would that do. Let's see right here. We run it. Takes it a few seconds, pops it up. Let's go and click on model. We can either do that or model results. It doesn't matter. And there you go, 95.3. Remember last time we had 95.9 for two of them? So this is a little less accurate because we dropped the number of trees from 15 to 10. We could have taken it up to 20. Now 20 might take a little bit longer to run, but let's see what it does. Just for giggles here, let's see. Give it a second. There it is. And let's look at the model. Let's see here. It might be more accurate, it might be less. In this case, it's actually less accurate, so that's where we come up with the idea that probably 15 is probably going to be our best bet here. Maybe a 16, but let's just see. And there it is. Let's just look at it real quick. And there we go, 95.4 on that one, so maybe a 17. Let's try that. And if we do 17, let's just do that real quick. Let's do that. We got 95. Now we got one that's almost 96 right there at the top. You know, or we could also have made this a 5 and see what that would do. Let's just see here real quick. See how quick and easy it is to fine tune these things. There we go. We're back to 296s and 195.3%. So that's how you do it. You can play with your, the length of the number of trees. Just remember, it'll take longer to come back the higher it is, and also the larger your data set is. So if I had 300,000 rows of data in here, and I was using 20 trees, that might take a while to come back. This only had 150 rows of data in it, so it's a pretty small data set here. Well, thanks for watching. I hope you found this helpful and interesting. You're going to be doing random forest on data, like it's very simply. And thanks again for watching. Please like and subscribe so you see all my other great videos coming out, and all the other videos I have on my channel for you on data science, data analysis, and all kinds of great stuff. Thanks again for watching, and have a great day.